Hello everyone, this is Professor Boyd from Union County College and I would like to welcome you to the Microlecture on the introduction of terms and their components. We will begin with the example of a basic algebraic expression, 2x cubed y squared minus 3x squared y squared plus 7x y cubed. By definition, a term consists of the multiplication of a number and one or more variables, each raised to an exponent. Later in the semester, there may be additional examples where you will also have the multiplication of a parenthesis with an exponent. Terms are always separated by plus or minus signs outside of a parenthesis. Looking at our example, you can use a visual cue of placing an invisible boundary line to the left of any plus or minus sign that is found outside of a parenthesis. The effect will allow you to take each term and parcel them or separate them apart. Once this is done, you can easily see we have an example that consists of 3 terms. Now that we understand how to separate our terms, we can now look at each term and break it down into its individual components. These are known as the parts of the term. First, we're going to parcel out our terms, and then we begin by looking at each term in its separate parts. The first part always being the number in the term is called the coefficient. And anytime we work with the coefficient, we keep the sign with the number. And you can see in this example, we have 3 terms, and the 3 coefficients are 2, -3, and +7. The second part of a term is called the literal part of the term. Now, when you hear literal, you should think literary or library, which brings books to mind. And what are in books but words, and what are words made of but letters? So when we come to look at the literal parts of the term, we are looking at the letters and their exponents, or more formally, the variables and their exponents in the term. Now we come to one of the most important rules for terms. And this rule says we may rearrange terms in any order as long as you keep the plus or the minus signs in front of the term. And just to demonstrate how flexible the movement of terms are, one example would be we could switch the +7 term with the -3 term in its place. You can also switch the +2 and the +7 term. And lastly, if you wanted to, you could switch all of the terms around. The final effect is, regardless of the order of the terms, your answer is always going to be the same. One of the best places where you can apply this rule at the beginning of algebra is in the circumstance where you've gone through and spent plenty of time doing a very long problem, and you turn to the answer key in a book, or you turn to an answer key on a computer system, and you find that the answer you have and the answer in the key is completely out of order from one another. It's all okay. This rule says everything is allowed to be rearranged without affecting the final value.